Section 7.4 talks about compound interest. So if an account earns interest during a period of time, that interest is then added to the principal. During the next cycle, the new principal is the old principal plus the interest earned during the last cycle. Thus, at the end of the next cycle, the account not only earns interest on the original principal, but also the interest earned in the last cycle. We say that interest is compounded. Thus, compound interest is the interest earned on the principal and the interest earned previously. How often interest is calculated depends on the length of the cycle or payment period. Below are some common payment periods. So if interest is compounded annually, that means we calculate interest once a year. Semi-annually means twice a year or every 6 months. Quarterly, that means 4 times a year or every 3 months. Monthly means 12 times a year or every month. Weekly means interest is calculated 52 times a year or every week. And daily, interest is calculated 360 times a year or every week. And make sure you know how many weeks are there in a year. There's 52 weeks in a year. Again, banks are defining 1 month to be 30 days and 1 year equals 360 days. So, Maria invests $3,000 in an account that pays an annual interest rate of 5% compound quarterly. How much does she have in the account after 1 year and B after 12 years? Well, if we're doing this using our simple interest formula, we know that starting off that our principal in both cases is $3,000 and our interest rate written as a decimal will be 0.05. So in 1 year's time, the interest would have to be calculated 4 times a year. All right, so we'd have to do our calculations, plugging in everything, working out. That answer then becomes the principal in the second quarter. We work it out. That then becomes the principal in the third quarter. Work it out. And that becomes the principal in the fourth quarter. And we work it out. Now, that is a real pain in the butt just to figure out how much she had after 1 year. If we have to do, for 12 years, we'd have to do 12 times 4 of those calculations. That'd be 48 separate calculations. To do something like that, you'd have to get like an Excel spreadsheet, line it up, and do it all the way down through 48 cycles. And this really stinks. So Part B really illustrates that we need a better way to compute the compound interest, since our current method is unrealistic for use for most situations. We will need to derive a formula for compound interest. So if we start with the principal P, then the total amount at the end of the first cycle is, we'll call it A sub 1 equals P times 1 plus RT. If we start with principal A sub 1, then the total at the end of the second cycle is A sub 2 equals A sub 1, 1 plus RT. Now replace A sub 1 by this. Well, notice you have two factors of 1 plus RT, so that becomes P times 1 plus RT. So now we've written the amount we have at the end of the second cycle in terms of original principal. And if we do it for the third cycle and plug in, we'll end up with a cube. In general, if we go through K cycles, we're going to get P times 1 plus RT to the K. So you let N be the number of times interest is compound per year. The length of the time for each payment period is 1 over N. So if I get interest is calculated 50 times a year, each cycle is 1/52th or 1 week. The number of cycles K is the time in T in years multiplied by the number of times compounded per year. So if I'm compounding interest 4 times a year for 12 years, that'd be 4 times 12, that's 48. So replacing T by 1 over N, K by 1 over NT, and A of K by A, you get this formula. And this is the compound interest formula. So again, you have this on your yellow sheet. If the principal P, present value, is invested at an annual interest rate R compound n times a year for t years, the amount of A, the future value, would be A equals P times 1 plus R over N raised to the NT, where R has been converted to a decimal. So let's go to our workbook and let's take a look at that example involving REIS. This is on page 114. Now we have a way to calculate this. So first thing, we're going to look on our yellow formula sheet and we're going to copy down the formula. A equals P times 1 plus R over N raised to the NT. Now let's identify our variables. P is 3,000. R is at 5% converted to a decimal. And how many times interest has been calculated per year? Well, it's compound quarterly, so n is going to be 4. And then we want to know how much is then to count after 1 year, so t equals 1. All right, so now we plug in. So that'd be 3,000. 1 plus 0.05 over, and here's 4. Raised to n, which is 4. And in this case, t is 1. So now, we're just going to put this bugger in our calculator. So I'm going to type 3,000. Oops, 1 too many zeros. Parentheses. 1 plus, do your fraction key, 0.05. Hit the down arrow, 4. Hit the right arrow, close the parentheses. Now do your caret key, 4 parentheses 1. Hit enter. And then we're just going to round that off to the nearest cent. So it'd be $3,152.84. Now for part B, we're doing exactly the same thing. The only difference is t is changed to 12. Now I want to show you a shortcut for doing this problem. So the only thing I'm changing here is that t is 12. Now I don't want to retype all this back in my calculator. Here's what we're going to do. I'm going to hit my up arrow. Hit my up arrow key again until I highlight what I typed in before. If I hit enter, that brings it down. Now the only thing I need to change here is that 1 to a 12. Oops. So I just kind of navigate over there. And I want to insert 2. I'm going to do second. Insert. Type 2. Hit enter. So that can save you some time, particularly as our formulas get longer and longer as we progress through the section. So this would round off to $5,446.06. Let's try problem number 2. And number 2, we're pretty much doing the same thing. I'm looking at this problem and saying, yeah, we got a bunch of computations we're going to need to do, but again, I'm not going to do it, retype the formula off from scratch. The only thing we're changing in this case is what n is. So let's see how this works. So our principal here is 10,000. Interest rate R, that's 0.04. And my time here is 1. So the only thing I'm going to be changing each time here is n. And then the formula, we have it in 2 spots. We have it down here and we have it up here. That's the only thing we're changing from parts A, B, C, and D. So I don't want to keep retyping this thing every single time. So I'm going to plug in 10,000. Oops, I did it in the wrong color. We have 1 plus R here is the 0.04. N here, well, we're doing annually. So it's over 1 raised to the 1, and T is 1. So the only thing we're going to be changing each time as we go for B, C, and D is that we're going to be changing that 1 that's light blue. So now I'm going to type in the calculator. So let's clear all this stuff out. So that gives us $10,040 or $400, excuse me. So 10,000. There's actually no rounding there. I could just put a plain equals here. Now for part B, we're doing exactly the same thing. The only thing is semi-annually, so now n is 2. So again, I don't want to retype all that in my calculator. I'm going to go hit my up arrow. So I've got that grabbed. And I'm going to just change this 1 to a 2. And that 1 to a 2. Hit enter. So we get $10,404. Okay, for part C, we're doing a quarterly, so now I'm going to do n is 4. Again, I'm not going to retype that whole thing. All I'm going to do is go over here, change that 2 to a 4, and change that 2 to a 4. That's the only thing I'm doing. So now we're going to have to round that off to the nearest cent, but that's okay. So that gives us $10,406.04 if we round that. And then finally we're going to do monthly. So we're just changing n to 12. This one we have to be a little bit careful when we enter this in the calculator. So here's what we're going to do. Hit my up arrow, grab that. Arrow down to, I can change that one easily, 12. Now when I change this 4, if I just type 12, I'm going to lose the parentheses. Now I could just finish it off by going close parentheses 1. The other way to handle it, which sometimes you might need to handle it later, is you go over here, you type the 1, and then you're going to do a second insert. And that's going to allow you to enter in the 12 without deleting anything or over typing anything. Hit enter. That gives us $10,407.42.